Hello, I'm happy to be back here to work with you in a new section of our course. And to start, we have this puzzle, this math puzzle. It's about Jenna, and I don't know why she did it, but she wrote all numbers from 300 to 399 on a paper. How many times did she write the digit 3? You can do the same thing, you can write all the numbers on a paper and count, or maybe there is a clever way, a smart way of finding out. We will get back to this puzzle later, and because right now we will start with chapter 6, rational expressions, on section 6.2, adding and subtracting rational expressions. And the first objective is to add or subtract rational expressions with a common denominator or a like denominator. So to add and subtract rational expressions with a common denominator, let's say you have polynomials p, q, and r. If you have the rational expression p over q, you want to add to the rational expression r over q. What you're going to do? You keep the denominator. Q, the denominator is going to be the same because they are common, they are like denominators, and you will add the numerators. The result or the answer is going to be the rational expression p over plus r on the numerator and q on the denominator. Well, the same thing you're going to do with subtraction. If you have p over q minus r over q, you will subtract the numerators and keep the denominator. Conclusion is to add or subtract rational expressions that have a common denominator. You add or subtract the numerators, and you're going to write the sum or difference on the numerator and keep the same denominator. And let's work on an example. We have here add 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. Check this. Compare the denominators and they are the same. So you keep the denominator 2p plus 7, right? You will add the numerators 4p minus 3 plus 3p plus 8. That's it. The next step is to combine like terms, because you have 4p that can be combined with 3p and negative 3 that can be combined with positive 8. And you will have 4p plus 3p 7p and negative 3 plus 8 positive plus 5 over 2p plus 7, and this is the answer. Now another example. Let's say we want to subtract 8y over y minus 2 minus 16 over y minus 2. Check the denominators. And if you have the same denominator, you can keep it. Keep the denominator y minus 2, okay? And subtract the numerators with 8y minus 16. What is interesting about this, if you check the numerator, 8y minus 6, you can factor out a number. Check if it's possible. If it's possible to factor it out, you have to do it. So we can factor out 8, and it will be 8 times y minus 2 over y minus 2, the denominator, right? Because we need to find the final answer. It needs to be the simplest rational expression possible. As you can see we can simplify, we can cancel common factors, y minus 2 in the numerator and y minus 2 in the denominator. And the answer, the final answer is 8. The result of the subtraction is equals to 8. Okay? You always need to simplify if possible. Now subtract, and we have 3y over y squared plus 3y minus 10 minus 6 over y squared plus 3y minus 10. Are the denominators, check it out, are the denominators the same? Yes, they are the same. We can keep the denominator, minus 10, okay, and then we're going to subtract the numerators, 3y minus 6. Cool. Now check if you can simplify. Check if there are any common factors or if there are any factoring techniques that you can apply. For the numerator, you can find a greatest common factor between these terms, 3y and negative 6. I think you can factor out 3, right? And can write 3 times y minus 2. What about the denominator? Well, we can apply here AC method. Do you remember how to apply AC method? Find A is 1, C is negative 10, so AC is negative 10, 1 times negative 10, negative 10, and B is positive 3, so B equals 3. Find two numbers that the multiplication is negative 10 and the sum is 3. Let's think a little bit. The multiplication negative 10 and the sum is 3. Maybe we can work with negative 2 and 5. Negative 2 times 5, negative 10. Negative 2 plus 5, 3. Yes. So we can factor it out. We can write, instead of this whole thing, we can write y minus 2 times y plus 5. Cool. This is cool because you can cancel out y minus 2 and y minus 2, and the final answer is going to be much simpler thing, 3 over, let me erase this so it's not too confusing. We factor it out, you don't need it anymore. So 3 over what? Y plus 5. This is the final answer. It's the simplest rational expression possible after we operate, after we perform the subtraction. Okay? Now, objective number 2. Identify the least common denominator of rational expressions. This is one step before we work with rational expressions with different denominators. So before, we need to know how to find the least common denominator. And you will see a bit later why do we need this. To add or subtract rational expressions with unlike denominators, you have to change them to equivalent forms that have the same denominator, or it's called a common denominator. This involves finding the least common denominator, the LCD, of the two original rational expressions. The step-by-step is, first you factor each denominator completely. The step number 2. The LCD is the product of all unique factors, each one raised to a power equal to the greatest number of times that the factor appears in any of the factor denominators. Let's work an example. It's better to understand when we work this on an example. Find the least common denominator of the rational expression. We have two rational expressions here. Forget about the numerator. Let me first check if you can simplify, but I think no, we cannot. So don't don't bother about the numerator. Look only at the denominators, right? And we have 6y and also 4y plus 12. Factor completely each denominator. 6y is equals to, so factor out the number, the coefficient. 6 is 2 times 3 times y, right? And 4y plus 12, well, we can factor out 4y plus 3, and 4 is something that we can factor out as 2 squared times y plus 3, right? Now we need to find the least common denominator. The least common denominator is going to be first we write down each unique factor. And we have 2 here and here, just need to write once, 2. We have 3 is here and there. And we have y, so write y. And another factor that we have here is y plus 3. So those are all the factors. And the next step, check the exponents. You're going to use the highest exponent of each factor. And we have 2 exponent 1, and we have 2 squares. So the highest exponent is 2. For 3, for y, and for y plus 3, we don't have any exponents, or just exponent 1. Great! This is the result. This is the least common denominator. Find out the number. 2 squared is 4. 4 times 3, 12. So the answer is 12y times y plus 3. This is the least common denominator among the denominators that we have seen before here. Those 2 denominators will result on this least common denominator. Okay, now another example. Find the least common denominator of the rational expressions. So we have a few rational expressions here. Now let's factor out. Focus on the denominators. And here and there we have these denominators. Factor out each denominator. X squared plus 4x plus 3. How can we factor it out? Well, my suggestion is apply AC method. And let's write here the AC method. For the first denominator, the first denominator that we have here is AC is 3. A times C, 1 times 3 is 3, and B is equals to 4. So we need 2 numbers. The multiplied is equals to 3, and the sum is equals to 4. And the pair of numbers, the multiplied equals to 3 and sum is 4, is going to be 1 and 3, right? 1 times 3, 3, 1 plus 3, 4. We can factor it out. X plus 1 times x plus 3. Cool. Now the other denominator that we have here, x squared plus 10x plus 21. Now we need to apply again AC method, but now we need a couple of numbers. The multiplied is equals 1 times 21, 21, and the sum of the numbers are 10. If you add the numbers, you have 10. And the answer is going to be maybe 3 and 7. And I know, I probably know the answer beforehand, and I find it quickly. What you have to do is write on a piece of paper a few combinations, and 21 is 1 times 21, 3 times 7, or yeah, that's it. So you're gonna find in the scratch paper a few combinations and find the right one for you. it takes a little bit more time. I'm just saying quickly because I already know the answers. I know, it's not fair. Okay, this is x plus 3 times x plus 7. And the least common denominator. Now we have the unique factors, right? So you need all the unique factors that you can see here. So one unique factor is x plus 1. Another unique factor is x plus 3. We have it twice here, but doesn't matter. You're just going to write it once. And another unique factor, x plus 7. This is the result. This is the least common denominator that we are looking for. All right, now we have another example. Find the least common denominator of these rational expressions. And forget about the numerators right now, focus on the denominators. So the denominators that we have here are this 5x squared minus 5, and another one is x squared minus 2x plus 1. For the first denominator, we can factor out 5, right? X squared minus 1. And you have to remember there's a formula that allows you to factor out this term here, this expression. And check difference of perfect squares. You can write down this as 5 times x minus 1 times x plus 1, right? This, if you review, if you remember, section 5.7, special cases of factoring, this is a formula that you can apply, difference of perfect squares. Now the next one, check this. X squared minus 2x plus 1, well, this is another formula that we can also use. You have to remember section 5.7, a squared minus 2ab plus b squared equals a plus b squared, right? This is a formula. You don't need to remember those formulas, but you need to have a formula sheet or somewhere in your notebook where you can find all those formulas. Easy to find. And you can say a is x, you can say b is 1, then you're going to have minus 2 times x times 1 plus 1. Yeah, this fits. That means we can write as x plus 1 squared. So let's write it down here. X plus 1 squared. Very cool. We have the first denominator all factored out. We have the second denominator all factored out. So the least common denominator is going to be all the unique factors. The one unique factor is definitely 5. 5 is the unique factor. Another one, x minus 1. Perfect, x minus 1. Another unique factor, x plus 1. So x plus 1. 5 shows up only once, and the exponent is 1. X minus 1 shows up here only once, and the exponent is only 1. And we have 2x plus 1. One is exponent 2, another one exponent 1, and we will select the highest exponent. The highest exponent is the square, and this is the answer, is how we find the least common denominator in this case, in this example here. Okay. Another example. Let's work on another example, and this is a very interesting one. It's simple. 1 over x minus 3 and 2 over 3 minus x. At first sight, you're going to see this and you're going to say, maybe they don't have this looks confusing. I don't know yet, but think about each one of the denominators. Okay, so x minus 3 and 3 minus x. Well, you can factor out -1 from each from one of each one of this. Let's say we factor out from the second one, -1. -1 times x minus 3, right? That means they are actually the same denominator. The same denominator, see? X minus 3, but kind of, they are the opposites. They are opposites, but you can rewrite this rational expression here as -2 over x minus 3. Then they will have the same denominator, and you can add or subtract or whatever using the rule for rational expressions with the same or common denominator. Okay, next we will examine objective number 3, adding and subtracting rational expressions with unlike denominators. That's the point. That's why we are working on lists and finding the least common denominator. To be able to do this, to add or subtract any rational expressions with different or unlike denominators. This step by step is that. Step number 1, find the least common denominator of the rational expressions. Step 2, write each rational expression as an equivalent expression whose denominator is the LCD found in step 1. Step 3, add or subtract numerators and write the results. And step number 4, simplify resulting rational expressions if possible. Again, better to understand working on an example. And the first example that we have is 15 over 7a plus 8 over 6a. First step, find the least common denominator. Let's write here on this side. Find the least common denominator. Okay, we have 7a and we have 6a. If we factor completely, we will have the first one, 7a. We cannot factor the number because 7 is prime, it's just 7a, but 6a equals 2 times 3 times a. Least common denominator, each unique factor, and you have 7 is a unique factor, 2 is another unique factor, 3 is another, and a is another unique factor. The least common denominator is going to be 42a, right? So apply, let's apply the least common denominator that just found here. Oops. We have to write down now each rational expression with this new denominator, 42a. Okay, so let's write down each, find the equivalent rational expression with the new denominator. For this rational expression, 15 over 7a, we need to change or to modify and have on the denominator as 42a, we need to multiply the denominator and the numerator by 6, right? Then we're going to have 42a on the bottom, and on the top we will have 6 times 15, 90. The next rational expression, we have 8 over 6a, and we want to find the equivalent. So multiply by 7 the numerator and the denominator. If you multiply the denominator by 7, it's 42a. If you multiply the numerator by 7, 8 times 7 is going to be 56. Right? Now you have, that's very good, because you have an expression or addition with the same denominator. You just have to keep the denominator 42a and add the numerators. 90 plus 56, the answer is 146 over 42a. At the end, don't forget, you need to simplify. If you can simplify, you have to simplify, and you can divide both numerator and denominator by 2, and then you have 73 over 21a. This is the final answer. Oops. Okay, now another example. We have subtraction. Subtract 5 over 2x minus 6 minus 3 over 6 minus 2x. But pay attention, this is an interesting example. If we try to find the least common denominator, you're gonna see that 2x minus 6 and 6 minus 2x, they are opposites. So we can factor out -1 from one or from another. Let's factor out the second one. -1 times 2x minus 6. So you can write down as 5 over 2x minus 2x minus 6 minus 3 over -1 times 2x minus 6. This -1 you can move to numerator, to the numerator. So you will have at the end the same denominator, right? 2x minus 6, and then you're going to have 5 minus -3. And this is equals 5 minus -3, 8 over 2x minus 6. Check if you can simplify. It looks like we may be able to simplify this because we have 8 that can be divided by 2. If you divide 8 by 2, you have 4. And 2x minus 6, we can also divide by 2. And we have x minus 3, and this is going to be the final answer. Never forget to simplify, because your final answer needs to be the simplest expression possible. Okay? And that's the answer for this example. Another example, and now we have here 4 over x squared minus x minus 6 over x plus x over x squared plus 5x plus 6. Okay, let's factor out each one of the denominators, and we will have x squared minus x minus 6, and let's use this scratch paper here by the side. Let's say this is our scratch paper. We can apply AC method. AC method, and AC is -6, B equals, B is -1. Two numbers that the multiplication is -6, and if you add is -1. Well, after you work on your scratch paper, you're going to find that you might use -3 and 2. -3 plus 2, -1, -3 times 2, -6. So this is equals x minus 3 times x plus 2. The other one, we have x squared plus 5x plus 6, and then let's use this scratch paper here by the side. Okay, then we will have AC equals 1 times 6, 6, and B equals 5. So the two numbers that we can find multiplied is 6 and the sum is 5 is going to be 3 and 2, right? Pretty cool, because we're going to have x plus 3 and x plus 2. The least common denominator is equals to the unique factors x minus 3, x plus 3, and x plus 2. So check here what we should do, because x squared minus x minus 6 is x minus 3 times x plus 2. To have the least common denominator, we need to multiply on the numerator and the denominator by x minus 3. See? By x plus 3, I mean. By x plus 3 is the one missing. So let's multiply x plus 3 and x plus 3 on the numerator and denominator, and then the other one, the other rational expression that we have here is x plus 3 times x plus 2. We still need, what's missing here is x minus 3. So we need to multiply the top numerator and the denominator by x minus 3. Okay? So here we have 4 times x plus 3 and x times x minus 3. Now we have an expression, two rational expressions with the same denominator. We can write all this thing here with one denominator, which is the least common denominator. And on the top, let's apply distributive property for x plus 12 plus, apply distributive property, x squared minus 3x. And we will have, as a result, x squared plus x plus 12 over x minus 3, x plus 3, x plus 2. That is going to be the answer. You might check if you can factor out this expression here. You can try to use AC method, but most probably you're not gonna be able to find a couple of numbers that multiplied is equals to 12 and the sum is equals to 1. So if we cannot find b equals to 1, if you cannot find, that's it. You cannot factor it out, you cannot simplify, and this is going to be the final answer. But pay attention, because sometimes you can find, you can simplify it a bit more. Right now, this result that you just found, I cannot think about a couple of numbers that we can multiply and find 12, and the sum is 1, That means that's it. That's it. This is the final answer. Now, the last example that we have, 7 over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. We need to find the least common denominator, and let's write down here all the denominators that we have. X minus 1, and factor it out. We cannot factor it out, x minus 1, that's it. X squared minus 1. This is a special case, difference of perfect squares. We can write as x minus 1 times x plus 1. And the other one, x plus 1, that's it, we cannot factor it out. Those are the 3 denominators. The least common denominator are the unique factors, and the unique factors that we have. X minus 1 is one unique factor, and x plus 1 is another unique factor. So this is the least common denominator. So we found the least common denominator, x minus 1 times x plus 1. Now let's work on the addition and subtraction. Let me write this again. 10x over, and x squared minus 1 is the same thing as x minus 1 times x plus 1, right? And minus 5 over x plus 1. If we want to find the equivalent expressions, we will make all the denominators equals the same as the least common denominator, right? So the first denominator, the first expression here, to make it equal, we will multiply on the bottom and on the top by x plus 1. So x plus 1 and x plus 1, right? And this the expression here in the middle, we don't need to change because it's already equal to the least common denominator. And the last one, we will have x plus 1. We need to multiply by x minus 1 on the bottom and on the top. Don't forget, both numerator and denominator needs to be multiplied by the same factor. Okay? And we can rewrite this. Now we will have a common denominator, the least common denominator on the bottom, and here at the top, 7 times x, 7x, and 1 times x, 7. I mean 1 times 7, 7. Next we have 10x. Next we have, this is a negative, right? So negative 5 times x, negative 5x, negative 5 times negative 1, positive 5. Cool? Now combine like terms. Let's check what kind of like terms we have here. We have 7x, we have 10x, negative 5x, and we also have positive 7 with positive 5. Combining like terms, we will have 7x plus 10x, 17x, minus 5x, 12x, and 7 plus 5, 12, over x minus 1 times x plus 1. Okay? Is that the end? No, check it out. Think if you can simplify even further, a little bit more. And we definitely can factor out 12 on the top. 12 times x plus 1 over x minus 1 times x plus 1. And this allows us to cancel out x plus 1 and x plus 1, right? And the final answer is going to be just 12 here as the numerator, and at the bottom x minus 1 as the denominator. That is the final answer. Well, good. We finished section 6.2. Now let's get back to this to the puzzle where Jenna wrote all the numbers. Why did she do this? We don't need to count. We don't need to do the same thing. We can just be clever. Let's think. This is the hundreds. This is the tens, and this the ones. Okay. From 300 to 399, all the hundreds are going to be threes, like 301, 302, 350, 370, 398, 399. So we're going to have 100 threes. On the tens, we will have from 330 to 339, 10 threes, 331, 332, 333, okay. Now on the ones you have 303, 313, 323, and each 10 by 10, each 10 units, we will have a repetition at 3, so we will have 10 more. The answer is going to be 100 plus 10 plus 10. In total, we will have 120 digits 3 on the paper that Jenna wrote. Well, thank you very much for watching this video, and see you soon on the next section.